Happy Snow Day, AAF students. I am, much as I enjoy looking at your faces every day, I must say, I am enjoying looking out at this beautiful snow while teaching you a lesson. So as annoying as it may be to get lessons while on a snow day, I do need to get through the curriculum. We won't get all the way through because we expect and we know that there are going to be some interrupted schedules during April for state testing. Even if you aren't state testing, the whole school has some altered schedules, which is going to cost us some time. And we don't want to rush or cut any material in order to finish our curriculum and get you ready for IB Pre-Cal next year. So here we go. Obviously, you are not going to take a quiz right now, but I want to remind you that this quiz will be on the next day that we see you, and we will do it first. It will be 20 minutes, and you will have a calculator. However, please be aware that even if you have a calculator, you have to show your setup and your work for full credit, right? And that's exactly what happens on the AP and IB exams, right? You're not going to get credit for just an answer. So if there's algebra setup to do, or changing the base, or and again, look at your point value next to each problem for guidance on how much work to show. We also haven't been too particular with any rounding rules, and I've told you in class that AP has a certain rounding rule for their exam, and IB has a slightly different one. So we've been kind of general with you. So for the first time, I'm going to start giving you one parameter. It's not exactly IB or AP, but it's just getting used to having a rounding requirement if you're going to round, right? So I love the kid that asked me, well, I want to write a half as 0.5, so how many decimal places? No. A half is exactly 0.5. That's not rounding. If you're going to round, so you have, for instance, an irrational number, I want you to write at least, meaning you can write more, but write at least 2 places past the decimal. So for instance, if my answer was E and I wrote 2.7, I would not get full credit. I would not get full credit with these rounding rules in place. Remember, E is 2.7, Andrew Jackson window wiper. And you can write all that down. You can write as many as you like, but for full credit with an answer that is E, you must at least write 2 places past the decimal. You can literally chop it off there, or you can round it. So 2.71 or 2.72 would be acceptable answers. And that is more like AP. AP just says 3 places past the decimal and allows that truncating or rounding for full credit. You can only lose 1 point in total for a rounding error. But why lose that point? So we want to start to get you used to that. So for this quiz, for no more than 1 point off, you need to follow the rounding rules. Anytime you're going to round. If you're not going to round, if your answer is E and you leave your answer as E, that's also full credit because that is the exact answer, right? And don't worry if that messes with your head. We have years to practice these rounding rules. Okay. All right. So again, quiz next time we see you. Next time we see you. You are all ready for it, right? There's nothing certainly on this video or even yesterday's lesson will be on the quiz. You know what's on the quiz, and you have practice problems for those as well. We've practiced in class. All right, so there is a homework that is a handout. We will check this, but for the few of you that have computer issues or don't get the email notification or don't know how to watch the video, blah, 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 if you don't have it the first day we're back, just show it to us the next day, but you will have additional homework, right? Because there will be another homework assignment. So for those of you that know you may have friends, use your social media, whatever's, your Snap, Tunes, Vines, whatever they are, and try to make sure that everybody knows that there's a video to watch with a handout to complete. Thank you in advance. Alright, so if you remember yesterday's lesson, or Tuesday's lesson, was on exponential graphs, and we talked about the slide swooshes. And remember that we had the definition of an exponential function, right? An exponential function. Function. Not an exponential expression, an exponential function. Right? Where the base has to be positive and greater than and not equal to 1, which should remind you of the log rules, right? Because what are logs? That's right. So we talked about why I can evaluate the exponential expression, parentheses -5 cubed, but I can't have y equals -5 to the x. Now, that's a little bit of a lie. Of course I can have this. This function exists. It exists. It has a graph, but it is not allowed in the family of exponential functions. Why? Because of these rules. And why? Because you know exponential functions are supposed to slide to the y-intercept, and swoosh off, or swoosh down to, concave, tough to draw, swoosh down to the y-intercept and slide along the horizontal asymptote, and the horizontal asymptote is at 0. Remember, this horizontal asymptote behavior is not the same as our rational function horizontal asymptote behavior. If a rational function has a horizontal asymptote, it levels off to the same value on both sides. That is not true for exponential functions, but hello, we're not in rational function land. So for exponential functions, the asymptotic behavior is only on one side, and the other side goes off to infinity. So -5 to the x does not follow this pattern. Therefore, it cannot be called an exponential function, right? -5 to the first power is 0. I'm sorry, to the 0 power. -5 to the first power is -5. -5 to the second power is +25. -5 to the third power is right? So you see, boop, 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 boop. That is certainly not a slide swoosh or a swoosh slide, right? To be an exponential function, the range behavior needs to be a slide swoosh or a swoosh slide. Same thing why you can't have a base that is equal to 1. I hope you can figure out that 1 to the x isn't an exponential function because I already have a place for the graph of 1 to anything, right? 1 to the 0, 1 to the -5, 1 to the -500, 1 to the 500, right? That graph is a constant function. It is not a slide swoosh, and I already have a family for that function, right? This does exist. It exists. I do have a graph. It's just not an exponential function. It's a constant function. Exponential functions have to be a swoosh slide or a slide swoosh, and it has to have the swoosh. That's what makes it exponential, right? That's why you have the expression, oh, it gets exponentially worse when blah, 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 blah. The swoosh, right? It gets exponentially better. My money grows exponentially. My my happiness decreases exponentially with the difficulty of my AAF class. Wah, wah. So, right? Characteristics, which you should have done last night, thought about the characteristics, and there were questions on the back of the homework from Tuesday's lesson, that if your base is between 0 and 1, you're decreasing concave up, and you swoosh down to the y-intercept and slide, whereas if your base is greater than 1, you start off very small, and you are still concave up, but you rise to the y-intercept and then swoosh off to infinity. So in your notes, I want to explore the relationship between the equations before the graphs. Right? What is the equation of log base 5 of x and the equation 5 to the x? What do they have in common? Before I ask that, let me ask you a question from first semester. And remember, you just had an IB problem with this concept on it. It never goes away. Do you remember the alternative notation for this? F composed with G. Looks like fog, right? No, honey, he took Delaney to physical therapy. What, hon? No, I'm doing a video for my class. No worries. Of course. Who did? Oh, okay. Okay, well, I'm sure Dad can get you after PT. Is that okay? Or do you want me to take you? Okay. I'm sure that'd be fine, huh? G composed with F. Of course, technically, I think I should write this, right, as F of X composed with G of X. G of X composed with F of X. Right? So open circle, this big fat open circle means composition. Right? You are responsible for that notation. Either way, if I look at it this way, F composed with G or G composed with F. So, back to R's. What does that mean? What does that look like? So, here's X. Put G into it. So, F composed of G looks like F with 5x in place of x. So I take log base 5, and inside there I put 5x. But wait a second. What is the exponent that turns 5? Whoops, sorry. Silly me. Five to the x. What is the exponent that turns 5 into 5 to the x? X. Hey! What about G composed with f of x? G with, right, inside of G, put all of f. What is G if you put f in place of x? Base 5, log base 5. What does this say, right? What did we learn about, what was the number 5 fun fact of inverses? Was it number 5? I think it was number 5, right? If two functions are inverses, their composition will be what? X. Therefore, f and g are inverses. Do you remember that? Log equations, log expressions, exponential expressions, their functions are inverses of each other. And what's the number 1 fun fact of inverses? Not number 5, but number 1. Number 1. Domain and range is switched. X and Y are switched, right? Now let's think about this for a minute. I know when you go to find an equation, you just mechanically switch x and y and solve for y. But let's think about this. Domain and range are switched, right? I made you do a characteristic list yesterday of an exponential function. If you know the domain and range of exponents, guess what you also know? Right? Foreshadow. That's called foreshadowing. Before we get to that, though, let me show you then how easy it is to find the inverse equation. I don't need to switch x and y and solve. I don't. If I give you log base 7 of x, you know what its inverse, notice I don't call it g anymore, I call it f's inverse function, because guess what? I had 1 to 1. Now I know you haven't seen a log graph yet, but you will. A log graph is 1 to 1, therefore its inverse will be a function. And what's my base here? Hello, there's the equation of the inverse. So how about the reverse? Exponential function is 1 to 1, therefore its inverse will be a function. Notice the function notation. Remember, that's another point sometimes you lose if you don't use function notation. So what is this? What's the inverse function to exponentials? Logs. What base? Oh, the same base. So how about these? Okay, maybe pause the video a minute and see if you can write these down. Whilst I sneeze. Thank you. Thank you. Okay. So if h is pi is an integer, no, it's not. It's an irrational number, but it is slightly bigger than what integer? That's right, 3. So what is its inverse operation? Its inverse function? Log base what? Yep. How about this? 4.2 is not irrational, right? It's not an integer, but it's rational. What is its inverse? Hold on a second, I'm getting a call. What's up, hon? Hi, I'm doing my video. That's okay, what's up? Oh, okay. And then Dylan got asked to go to Robert Frost. Okay. And I didn't know the time. Okay. Yes. Alright, I'll call you. Bye. Thanks for waiting. So next one. Where's the base? What is the base? Try to avoid calling that ln, right? I know when you first see it, either say ln or log of the natural number. And what is the natural number, but it's not natural to you yet? That's right. 2.7 Andrew Jackson window wiper. So what is the exponential function that is the inverse of ln? E to the, right? And I kind of hinted that to you. If you look at your calculator button, there is an ln button, and right above it is e. So conversely, if I give you e to the x, which is just right? E is not an integer, and it's not rational. It's irrational, but it is just a number slightly smaller than 3. Don't be afraid of it. So its inverse is log base who? It's just we don't write it that way. The log of the natural number is not written as log, right? Don't write it that way. Write it as the log of the natural number, and the argument is x. Okay? So no switching x and y and solving. If you know that logs and exponents are, their functions are inverses of each other, then you've got no work to do. So let me recall and notice that I changed the background to look like the background from Tuesday's lesson. That yesterday, or Tuesday, you took notes on given y is equal b to the x and that b is equal to 3. We talked about always plotting the point 0, 1. And we had the, and the reason was because plugging in 0, right? Plugging in 0 to an exponent always turns a base into 1. Plotting the point 1 comma b because plugging in 1 for an exponent didn't change your base. And we talked about the x-intercept not existing, because to find an x-intercept, you plug 0 in for y and ask yourself, what exponent can you plug in to any base and generate 0? And the answer is nothing, honey. So since no value of x will generate y to be 0, we drew our ha at y equals 0. Well, again, let me remind you, what is the number one fun fact of inverses? What is it? So that means that, now you should write this down, given that y equals log any legal base to the x, and I'm going to use base 7, you are not going to plot the point 0, 1. Guess what point you're going to plot? And you're not going to plot the point 1 comma b. What you going to plot? Yep. And, ready for mind blown? You ain't going to have an asymptote at y equals 0. Where are you going to have an asymptote? Because if there is no x-intercept on exponents, there is no what? Y-intercept on the inverse. So you're not going to have an asymptote at x equals 0. You're not going to have a horizontal asymptote. You're going to have a, vertical asymptote. Oh my gosh. Now think about this. Do you remember the rules on logs? Do you? Right? What are the rules on logs? The base, right? That base has to be greater than 0, and the base cannot equal 1. Well, my base is 7, and it is greater than 0, so I'm okay there. But what about, what's true about the argument? What's our rule on the argument? The argument has to be greater than 0 and never equal to it. Because there's no y-intercept. Because logs are the inverses of equations, and logs are the inverses of exponents, and exponential functions don't have x-intercepts, right? So logs can't have y-intercepts, and if they can't have y-intercepts, well then x can't be 0, because how do you find a y-intercept? You plug in 0 for x, OMG. It all makes sense. I'm just saying. Yep, math is cool. Alright. If you go to Canvas and you look for the handout relating exponential and log graphs, you should print this out. This is not your homework, but will go with my notes, or you can just copy this all down in your notes, but you might want to pause the video and go print out this handout. And my next slides are going to go with this handout. Okay, I assume that you have printed it out, or you're just copying this over in your own notes, which is fine. I want to graph not log base 7 of x, but 7 of x, because truth be told is that logs are new to you. Exponents aren't, right? So it is more likely that you remember how to graph exponents because you're more familiar with exponents. You can mentally plug in points to an exponential equation and graph it pretty quickly. It's not as likely you'll remember logs or how to evaluate logs, plugging in and getting logs, right? But if you remember that logs are what? Exponents. Think about my handstand, right? When I'm talking about their functions, they're inverses, and I inverted myself. Wah wah. So, if I say to myself, how do I graph 7 to the x, right? I have all these points, right? Since the domain is all real numbers, I can plug in 0, positive numbers, and negative numbers. And I know how to graph it, right? I get 0, 1, and I get 1b. I have my horizontal asymptote, and I slide to the y-intercept, and with a base that is 7, swoosh very quick. Oh, that looks linear. Oh, it's supposed to always be concave, right? Concave up. Oh, that's terrible. Slide swoosh. What's the number one fun fact of inverses? If I don't actually want you to graph 7 to the x, instead I want you to graph log base 7 to the x. If I already have this table, because I can very quickly evaluate 7 to the x, 7 to the 1, 7 to the, right, 7 to the 0, 7 to the 1, 7 to the 2, blah, blah, blah. I very quickly know how to do this. All you have to do is what? Switch them, baby. If you have the table for 7 to the x, you have the table for log base 7 to the x. You just switch x and y. That's it. Instead of the point 0, 1, you have the point 1, 0. Instead of the point 1, 7, you have the point 7, 1. Instead of the horizontal asymptote at 0, you have a vertical asymptote at x equals 0. Now, here's the cool thing about the shape. You still have a slide swoosh. But remember, exponential functions are always concave up. What do you think log functions will be? That's right, they're concave down. I still slide along the asymptote, but I want you to notice here, when I'm sliding along the horizontal asymptote, I slide and grow really slowly till the y-intercept. Swoosh! Very quickly, right? You're going to do the inverse. You are going to slide, but you're going to slide up along the vertical asymptote quickly. But you're going to be concave down. To not the y-intercept, but to the what? X-intercept. So you're going to slide quickly in a short space. You're going to rise from negative infinity to x equals 1, right? Or to y equals 0. So from y equals negative infinity to y equals 0, all in this space, you have to rise very quickly. But then after the x-intercept, you grow slowly. But you do keep growing. You do keep growing, just really, really slowly. And you are concave what? Down. Hey, what's the number 3 fun fact about inverses? Do you remember? I hope it was number 3, by the way. Inverse graphs are symmetric across the line. Y is the same, or was switched into x, or x was switched into y. Wow. I heart math. Right? Right? Log graphs, NBD, no big deal. Right? They are still slide swooshes. Exponential functions really are swoosh, slide. Log graphs are slide, swoosh. I wonder how many math teachers teach exponentials and logs like this. Do you think I'm weird? I think I'm weird. But it's okay. Alright, let's look about our characteristics. So I'll wait a moment while you refill in this. Now notice this is exponential, right? This is an exponential graph with my base is greater than 1. So that is horizontal asymptote, slide slowly, swoosh quickly, right? Here are the characteristics you copied down yesterday. So what if I ask you to do a log characteristic list with the base this time of 7? If you don't remember the characteristics of logs, but you do exponents, and let's be real, the exponent characteristic list ain't that hard, what's the number one fun fact of inverses? Domain and range are switched. So the domain of logs, duh, the argument has to be positive and is not allowed to be 0. But the range is all real numbers, right? Think about that behavior next to the vertical asymptote. Log graphs are functions, are one-to-one, and are continuous once the domain starts. That's what continuity really means. Once the domain starts, are you continuous? Continuity cares about breaks in the domain. Once the log graph starts, there is no breaks in the domain. Now remember, exponential functions had no x-intercept, but had a y-intercept of 1. What's the number one fun fact about inverses? So log equations and log graphs, have an x-intercept of 1 and no y-intercept. They both have no absolute or local mins or maxes. With a base of 7, the log graph, remember when I should have drawn this, if the exponential graph is horizontal asymptote, slide, swoosh, the log graph is horizontal asymptote, slide quickly, swoosh slowly. Right? So still increasing over the entire domain. So what's wrong with this? Why is that? Why would that lose me a point or a half a point? That's right. These increasing and decreasing by definition are intervals over the domain. So my domain is not negative infinity to infinity, right? I need to copy, paste. But decreasing never. Hey, what's true about concavity? I am not concave up when I'm a log graph. I am concave down, and I do not change concavity. There's no point of inflection. And I am concave down, again, don't be caught. I'm concave down over the domain. Copy, domain, paste. I don't have a horizontal asymptote at y equals 0. I have a what? Oh, snap. If you know exponents, you know logs. Because what are logs? Yep. Alright, let's get out your calculator and look at this on my calculator. What the heck? Ace of base, baby. Right? Now, I know this calculator has a place where I can enter base 7, but not all calculators do. So this is one place where changing your base is very convenient. I changed from base 7 to base E, but that means I get the same graph. So when I look at this, I changed to base E. You can change to base 10 if you like. But I want to show you, when I hit just a zoom 6 window, I want to show you what the graph looks like. Oh, that was me throwing up, in case you didn't know. That's a terrible graph. That is a terrible representation of a log graph. I don't see the horizontal asymptote, the vertical asymptote. I don't see sliding along the vertical asymptote. I kind of sort of see the slow swoosh. But come on, this is terrible. Now, if I hit trace, notice when x is equal to 0, what is y? Nut and honey. And I do see, right, I do see that as x gets larger, y is getting larger, but just by teeny tiny bits. And then, of course, if I go over here, right, you can't see your curve. Well, what's happening, right? So you need to know what a log graph really looks like. Now, I can manipulate my window, probably, and make this look a little bit better, but not much. The calculator's just not great at this kind of stuff, right? I mean, a little better, I guess. But if you draw me that graph on a test, man, it's not going to get full credit. Right? You have to show me the very important characteristic of log graphs is the vertical asymptote and the fact that the range is negative infinity to infinity. It gets to negative infinity super quick. It gets to positive infinity, and that's right. You don't actually ever get to either infinity, but you know what I mean. You approach positive infinity very, very slowly. You approach negative infinity very quickly. But the range is infinite, and your graph has to show that. Now I want to show you again, in case you don't know, if you do have this type of calculator, you can hit Math, and you arrow down. There's the cube root, there's fifth root if you ever can. You know, again, I don't really use the fifth root. I just type something to the 1/5. I just use my exponential rules. You'll use Math 8 and Math 9 a lot in calculus. I don't use the summation too much, but you might in pre-cal. There it is, log base. If I hit that, here's where I'm allowed to enter base 7 of x. And I'll just go over here, make this a thick line, so you can see that indeed that is the same graph, right? That is the power of changing your base, right? You can change your base and get the exact same values, and you can change to any base, right? I could also, of course, have done base 10, log x, parentheses, don't forget Aunt Sally, divided by log 10, and I should close my parentheses, but I don't have to. And show you that that also is the exact same graph. Right? You could look at your table and see that, of course, when x is 0, you have an error. When x is 1, you get 0, right? And then all these values are the same. Right? ln of x over ln 7, log x over log 7, log any base of x over log same base of 7 gives you the same results, right? Oh snap, why is line 3 different? Where is it going? Ah, dummy. I hit 10, right? Silly. There we go. Right, now you see that y2, y3, everybody's the same. Okay. Next, what if my base isn't greater than 1, but my base is between 0 and 1? First, I think about the exponential graph, and I realize that's not a slide swoosh, it's a swoosh slide. But if I actually want you to graph log with a fractional base, right, a base between 0 and 1, remember our bases are not allowed to be negative and our bases are not allowed to be 1, I just switch those points. Exponential equations must have the point 0,1. Log graphs must have the point 1, 0. Exponential graphs must have the point labeled for full credit on our tests and quizzes. Must have the point 1 comma the base. Your log graphs must have the point base comma 1. And then the shape. And of course the asymptote. So 1, 0, 1/7 comma 1. Vertical asymptote, you still have to slide quickly along the vertical asymptote, hit the x-intercept, and then swoosh slowly. Right? Do you see the slide? Right. Slide quickly. Swoosh slowly. It's a little bit harder to see, but if I were to superimpose on here log base 7, I'm sorry, y equals 1/7 to the x, right? Ah! That graph is still symmetric because you have inverse operations. These two graphs are also symmetric across the line, y equals x. Okay. How about characteristics for this one? With a base of 1/7, if you know your exponential characteristics for any base, by the way, between 0 and 1, these characteristics don't change, right? That's also really sweet. Your characteristics, as long as you know your base is either between 0 and 1 or greater than 1, I don't care whether you're in logs or exponents, your characteristic list does not change. Right? There's my characteristics for, there's my characteristics for exponentials. So how about for y equals log, log base 1/7 of x, right? My base is between 0 and 1. Domain and range are switched. Argument has to be greater than 0. Range is infinite. From negative infinity to infinity. Yes, yes, continuance once the domain starts. X-intercept at 1. No y-intercept. No maxes, no mins. Now, what about the log graph, right? Remember this one, the exponential graph, does this. Your log graph does this, right? So that decreases, so does not increase, but decreases over its domain. And hey, this one, like exponential functions, regardless of the base, you were concave up, right? This is still concave up. But log graphs, when your base was greater than 1, was concave down. But how about between 0 and 1? Right, it's concave up. So there's only one concave down graph here, and it's your log graph when your base is greater than 1. So concave up over the domain, no concave down, but no horizontal asymptote, still a vertical asymptote, and not at y equals 0, but at x equals 0. Right? Crazy. Again, if you want to look at this on your calculator, I'm just changing my base to 1/7, right? Oops. I mean, ew, right? You can see the end, you can see it's concave up, but you again don't get the asymptotic behavior, right? That looks like actually a radical function, a negative, right, which is half of a sideways parabola. That's what that looks like, the bottom half of it. Remember when we did amputating x squared, right? That's what that looks like, but it is not. It is not. So your homework is another handout, and it is on Canvas, and it is graphing. So, practicing graphing exponents and logs, but with a focus on logs, and some questions about the shapes and characteristics. I don't have you make a characteristic list, not bad to practice though. If we have another snow day, I will be sending you another lesson to watch by video, and just continue on as if we were in person. Technology, yay. And the next time we see you, we will give you that quiz. So be sure to practice when you don't want to come in cold to take that quiz. You want to have kept up some of your practice on the solving log and exponential equations. Alright? Have a nice rest of your snow day.